and they're really expensive. You're talking about $3 to $5 of cost for the most simple and most inexpensive Wi-Fi Bluetooth chip. We at Jiva are solving this problem. Our value proposition is low power, really cheap, and very small form factor solutions. So to give you an example of kind of systems that you're talking about, on the left are an example of devices that exist nowadays in the market. On the top, we have a long-range home automation sensor. At the bottom, we have a Amazon dash button. As you can see, both these devices actually require a pretty big and bulky battery. What Jiva is proposing is that with our technology, we can convert these devices into something that look like these. So we're talking about devices which would be size of a thumbnail, can use really, really tiny, small batteries, can use flexible antennas, and basically build devices which can be embedded into any object that you can think of and becomes ubiquitous, and you would never have to think about connectivity at all. So our secret sauce is a technology that is called ambient backscatter, which was developed at the University of Washington here in this building. So the way I like to explain this technology is by using light. So the way typical radios, be it Wi-Fi or cellular radios work, is you can think of it like a light. So if I want to talk to you guys, I can use a flashlight and turn it on and off. And that way you can figure out whether I'm transmitting a bit 1, which is light on, or bit 0, which is light off. But as you can imagine, generating that light consumes a lot of power, is really expensive and really big solution. What at Jiva we do is something called it's called backscatter or reflections. So rather than using a flashlight, we can use a mirror and reflect ambient light, and you can look at that reflections and figure out what we are trying to communicate. And it turns out using a mirror is a really tiny solution. It's really cheap, and it's about 1,000 to 10,000 times lower power.